Good evening, Colin, consulting engineer with Juniper Networks. I was up at 2:30 this morning to drive down to a customer site to deploy an MX480, and it went smoothly for the most part. We did have a hang up with an L2 circuit, and I wanted to kind of run through what we saw and the steps that we took to fix it. So this is actually a video that's geared towards this particular customer, but I kind of want to make it a bit generic so that I can share it with other folks as well. So forgive the context here if you're the intended customer. If other people think this is useful, I just want to make sure I'm not mentioning orgs and names. So the work today, like I said, was installing a router. This is a P router for an MPLS network. So it wasn't overly complicated. There were a number of LDP neighbors, OSPF neighbors, BGP. We did need to make sure that all came up. And I'm going to jump into where we started running into issues with an L2 circuit. All right, so if you've seen this lab before, great, but I assume some people haven't. I've got a very busy screen here, but essentially the bits you need to know are these. These are the computers that I'm going to be testing against. Basically, the systems that are at either end of this CCC link, this circuit cross connect. These routers here are PEs. These routers here are Ps. Now in this case I was working on a P router, but it was a termination point for some CCC links. Just for the sake of my lab, I'm doing it into this PE. Steps are the same, everything looks the same. CCC configurations are pretty straightforward. Basically all you need is MPLS and LDP running. We're going to be working on this PE router number 6 here. And in this simulation, this other PE router we're going to say is the remote peer. This is a device that we have to assume was configured correctly because it was working, and we've just swapped this router down here for an MX480. So we're not even going to look at the configuration on this one. We're just going to be dealing with this one, which is what this screen is here. And I've got us in the resting state. This is basically where we started troubleshooting. I've already configured my L2 circuit. You can see that here. And we'll be using trace options. I'm just saving myself some typing by already having them set and active. And in this case, I've got a neighbor, 172.31.109. That is the loopback interface for this other PE router that my client's connected to. The interface locally is GE009. We can see that here, and it's the same up here, although again, that doesn't really matter for the sake of what we're doing. And then we have a virtual circuit ID, and this does have to match on both sides right here. On the router that we were using, we had 3 different virtual circuits. It's the same consideration for all 3, so I'm only working with one here. At this point, this link is down. So you can see that this is pointing at GE009. If we go look at that, show interface GE009. If some of you are clever, you're already starting to get a sense of where our problem might lie. I've got my encapsulation set. There's something else missing, but we'll get to that. So we're in the operational mode, and just run the basic L2 circuit connections. And I see the connection here, and I see this flag set that says NP, which here means interface hardware not present. So my first response to that, if it hadn't been so early, I might have caught this faster, was to turn on trace options. So I know it says hardware isn't present. I'm like, wait, I know that interface is there. I do a show interfaces GE009 terse. I can see that it's up. Great. So I go back into the configuration, turn on trace options. In this case, I'm just going to activate them. L2 circuit, trace options, hit quit, and I take a look at those. And we'll see if I can generate some stuff. There we go. And this is basically where I realized what was going on. I have, I don't know if I see the IFL error here, but I saw an IFL error when I was doing my troubleshooting this morning. And it was pretty straightforward here. look, there's a logical interface defined, and I do not have a logical interface defined because I don't have a unit number in that configuration. So there's problem number one right there. So went in, edit interfaces GE009. Again, we see it's very minimal. We just do a set unit 0 family CCC. That's it. Top, commit, quit. All right, so now let's take a look. Show L2 circuit connections. All right, progress. Got a different error message now, though. Now I see that it says OL, which means no outgoing label. All right, well, let's see if our trace options say anything new. We can say show log CCC. We see a little bit more information here. DC timer, status update, status not given, imp failure to create or update. And here is the key. No outgoing label. Now, we can take this a step further. I knew what this meant, right? Like, I saw that and I was like, oh man, I know what I missed. You could also look at the interface that the traffic is running over. In this case, my path between these devices is here to here and then back the other way. So if I were to do a monitor traffic interface GE002, no match, no resolve matching. And in this case, I'll do the host because I know that this link is going to be between these two loopbacks here, 109 and 106. So I can just define this host, this loopback, as being a interesting traffic. So I'll do host 172.31.0.109. We'll just wait for a message to pop up here. And if you're reading ahead, you already know what's going on because you're looking at this stuff. All right, so, you know, I probably want to do extensive on this. Actually, I don't think I need to do quite extensive. I can just do detail, and I'll get enough information. There's UDP, there's our LDP packet. Let me stretch this out a bit so it's a little easier to read. Oh, that didn't help. It just made the window wider. Anywho, it doesn't matter. The interesting bit here is that we're looking for this 646. This is label discovery protocol. So when LDP sends a discovery, hello basically, it sends it over UDP to that port. And this is kind of right here is this address. What this is telling us is that LDP is trying to do discovery against our loopback interface. And what that means is that our loopback interface needs to be in LDP. Guess what? It ain't. And usually it doesn't need to be. But if you're doing CCC, it's absolutely a requirement. So now what we do is we do a set interface LO0.0 show, great, top, commit, and quit. Show L2 circuit, connections. Look at that. Now, you can see this IP address that I have here. I got 10.100.100.1. I've got .2 down here. What we'll do is we'll jump onto this client 6 here, and we should be able to ping 10.100.100.1. And there we go. And just as the proof here, get back in, pull this back 1, do a commit, that ping should die. And it does. You can see it dies right there. Start it up again. Roll it back again to reapply that configuration. And boom, you're back in business. So that was the fun. There's a little bit of tidying. Actually, adding this loopback was interesting. It fixed an OSPF adjacency problem we were having as well that was being formed over LDP. So that was kind of a benefit, but out of the scope of this discussion. And there's a little tidying we need to do tomorrow morning. But overall, everything went really well. And hopefully, if you're running into CCC problems, this has been informative. Have a good rest of your night. I'm going to go to sleep because I've been awake for a long time.